JMB, how are you all? I hope you all are good and I welcome you all to my YouTube channel. My name is Prince Ranpara and I am a PhD scholar in the Department of Chemical Engineering at the Indian Institute of Technology, Ropar. So this is my very first teaching video on my YouTube channel. So here I will be explaining, or here I will be sharing clear, simple and detailed understanding of the fundamental topics of the chemical engineering, which will be very helpful for you to learn, understand and to gain the fundamental knowledge in a very step-by-step systematic manner. So firstly, I'm planning to complete the core chemical engineering subject, which is the CRE, chemical reaction engineering. So chemical reaction engineering is the core subject of chemical engineering. So firstly, I'm planning to complete the fundamental knowledge of, or the fundamental topics of chemical reaction engineering in a step-by-step manner, right? So in my video, in my YouTube channel, I will try to explain you all from a very basic. So I will try to create the basic foundation, and with the progress of the time, we will dwell deeper more into the fundamental knowledge of the chemical reaction engineering, which is the core subject of chemical engineering, right? So let's begin the learning. So we'll start with the core subject, which is chemical reaction engineering. So chemical reaction engineering means, so let's say in chemical reaction engineering, we'll understand the design of the reactors and the chemical kinetics of the reactors, which are the heart of the chemical engineering, right? So let's say chemical reaction engineering is the core subject, okay? So how we will proceed further in the video. So in my videos, in my YouTube channel, I will try to make the individual videos with respect to the individual topics, so which will help you to search on the YouTube and to gain the knowledge with respect to the each and individual topics. And for the each and individual topics, I will also try to solve the examples, numerical examples, which will be very helpful for you to learn and understand in a practical manner, right? So in chemical reaction engineering, let's say what is chemical reaction engineering. So chemical reaction engineering, right? So chemical reaction engineering, which means, let's say engineering means, let's say we are doing any reaction means, with respect to the time, there are something changes inside the reactors and the reactants will get converted into the product is called the reaction. Okay, so let's say we have the reactor system in which we are feeding some chemicals, and chemicals will interact, they will react and form the product. Okay, it's called the chemical reaction, right? And engineering means, as a chemical engineer, we will try to scale up the reactor. We'll try to scale up the reactor system. Let's say we are carrying out the reaction in the chemical laboratories, which are at a very smaller scale, in the round bottom flask or beakers or conical flask and etc. Right? We are using a very small beakers for the chemical reaction to understand the chemical reactions. So as a chemical engineer, and as the term engineering means, will scale up all those reactor systems at the laboratory scale to the bigger size of pilot plants. Pilot plants can be scaled up to the industrial scales, and industrial scale can be scale up to the commercialization of the reactors with very huge size of the reactors, right? So let's say first of all we need to understand the mole balance. So mole balance means, like the chemical species. Let's say we have the reactor system, right? So in reactor system, some chemical species will enter into the reactor, they will react, they will interact with each other, they will react, so reaction will occur inside the chemical, inside the reactor, into the reactor reaction environment. So after the reaction, the chemical species will leave the reactor system. Okay, and there are possibilities like the chemical species may even accumulate inside the reactor system. So we'll understand all these and we'll account all these understanding of the chemical species entering into reacting, leaving the reactor, and accumulating inside the reactor by understanding the mole balance. So in chapter 1 we'll understand the mole balance of the different reactors, in which we'll also understand the rate of the reaction. Okay, at what rate the reaction will progress, or the reactants will get converted into the products. Okay, so in order to understand the individual species mole balance, so we'll understand the general mole balance equation for the different industrial reactor systems. So we have batch reactor, we have continuous starting reactor, we have packed bed reactor, we have plug flow reactor, and the fluidized bed reactor. So in chapter 1 we will cover all these topics. Okay, so we have understand what are the topics we are going to understand in the chapter 1. So in chapter 2, which is the conversion and the reactor sizing, so after understanding of all the general mole balance equation of the all different types of industrial reactors, we'll understand the conversion and the reactor sizing. Reactor sizing means the volume of the reactor, right? So conversion, we'll understand the conversion. If we are using the different types of industrial reactors, let's say batch reactor, semi-batch reactor, continuous starting reactor, plug flow reactor, packed bed reactor, or fluidized bed reactor, how the conversion will change with respect to the volume of the reactors. And in order to achieve the specific conversion, how much amount of time, or let's say what is the time required to achieve the specific conversion for the desired volume, right? So we'll also understand the design equation of batch reactors, continuous starting reactor, packed bed reactor, plug flow reactor, and we'll also understand the different sizing of the reactors. Okay, and furthermore we'll also understand the arrangement of the reactors. Like, let's say for example, if we are using batch reactor followed by continuous starting reactor followed by packed bed reactor, or let's say vice versa, if we are using the batch reactor followed by plug flow reactor. So what is the best arrangement of the reactors for the optimized reaction parameters? Let's say we need to achieve the most desirable conversion, we need to achieve the highest yield or selectivity of the desired product. So we'll understand all those things in the second chapter. We'll also understand the space-time and space velocity and further more topics. In chapter 3, we'll understand the rate laws. So first of all, we'll understand the definition of the rates. What is the rate law? What are the rate law equations? We'll understand the reaction rate constant. Okay, we'll understand the RNS plot. We'll also understand the dependency of temperature on the reaction rate. If we are changing the temperature, then how it will affect the rate of the reaction. Okay, we'll also understand the power law models and elementary followed by the elementary rate laws and the non-elementary rate laws, right? So after understanding of these, in fourth step in the chapter 4, we'll understand the stoichiometry. So in stoichiometry, we'll understand in detail about the specific species. Let's say as per the stoichiometric equation, or as per the reaction stoichiometric equation, how we'll understand if we are having this liquid phase system, if we are having gas phase system, so we'll try to derive the relation between the concentration with the rate equation and the conversion. Okay, so we'll try to find out the relation between the rate of the reaction with respect to the conversion and or the concentration, whether the reaction is taking place in the liquid phase or the vapor phase, right? So we'll also understand the reversible reaction and the equilibrium conversion. Now in fifth chapter, we'll understand the in fifth chapter we'll understand the isothermal reactor design. Okay, so in fifth and sixth chapter, we'll understand the designing of the industrial reactors. Okay, how we'll design based upon the mole balance, rate flow, stoichiometry, the design equation of different types of industrial reactors, the relationship between the rate equation the relationship between the rate of the reaction, the conversion, the concentration, the volume of the reactor, pressure, okay, all these things, and we'll try to derive the performance equation of all the industrial reactors like batch reactor, continuous starting reactor, PFR, PBR, today's batch reactor. We'll also understand the arrangement of reactors in series or in parallel. If we are using the packed bed reactor or the fluidized bed reactor, we'll also understand the effect of pressure drop in the reactor system, and we'll also understand how this pressure drop will affect the reaction parameters like the conversion, selectivity, yield, concentration. Okay, and we'll also try to compare like if we are not considering the pressure drop and if we are comparing the pressure drop, what are the changes. We will investigate in a very detailed manner, right? Okay, so in chapter 7 we'll try to analyze the data which are obtained from the reactor system using the integral method, graphical, differential method, numerical method, and the nonlinear regression. Okay, so in chapter 8 we'll understand the multiple reactions, let's say, in which we'll understand with the basic definition of the reactions. We'll understand the selectivity, yield, conversion, and let's say in our reactor system, if the reaction progress, so reaction is occurring with a single reaction or the forward reaction, reverse reaction, or we can say reversible reaction, irreversible reaction, or let's say if we have only one reaction, let's say A plus B gives C plus D. So whether this reaction occur in a single reaction or it also includes the intermediate steps for the conversion of reactants into the product via multiple reactions, right? So we'll also understand those steps. Okay, and we'll also understand like whether the reaction follows whether the reaction is occurring in a single way, one way, or whether the reaction is occurring in a parallel way which means let's say if A is forming some intermediates and intermediates are reacting with some other species and some other species are reacting to form the product. Okay, are called the parallel reactions, means with let's say with one reaction we have parallel reactions are going together, and series of reaction, which means if A will form to intermediates, intermediate form to another intermediates, will then convert it into some products, and products will get converted into some other byproducts, or likewise. It's called the series reaction, and we'll also understand the complex reaction as well. Okay, and in chapter 9 we'll understand the reaction mechanism, the pathways, and the bioreactions and the bioreactors. So the topics which includes in the chapter 9 is pseudo-steady state hypothesis, enzymatic reaction fundamentals, Michaelis-Menten equation, inhibition of enzyme reactions, the bioreactors and biosynthesis. Okay, so in chapter 10 we'll understand the catalysis and the catalytic reactors. So we'll start with the understanding of the catalyst, like what is catalyst, right? If we are incorporating the use of catalyst into our reactor system, then we'll understand in the presence of catalyst how the reaction will progress, or how the reactants will get converted into the product through the catalytic reaction, right? So we'll also understand the synthesizing of rate laws. We'll understand the detailed reaction kinetics or the detailed reaction mechanism utilizing the catalyst. So here the catalyst, I'm trying to say the heterogeneous catalyst, right? We'll also understand the rate limiting step or the rate determining step, right? We'll also analyze the heterogeneous data for the different different industrial reactors, and if we are using the catalyst, then with the progress of the reaction there are chances of catalyst to deactivate. Then we will also understand the catalytic deactivation. What are the reasons the catalyst will deactivate, and what are the possible solutions for the regenerability of the catalyst, right? And also so these are the first 10 chapters and the topics which I'm going to discuss, and these are all the topics which I'm going to discuss in my YouTube channel, right? So for each and individual topics I will try to make different videos with respect to the each and individual topic, so which will be very helpful for you to learn and make the notes and to solve the numerical examples. Okay, so I hope it is clear, right? And so thank you for watching my YouTube video. I request you to please subscribe my YouTube channel, please like the video, please share this video with your friends. Okay, and if you are having any question or suggestion, please feel free to comment below, and I will try my best to reply the comments. Okay, and until then, stay focused, keep learning, and stay curious. Okay, so thank you for watching my video. Jai Ambe.